This video is an introduction to polynomials. So we're going to start with types of polynomials. We're going to look at a lot of new vocabulary today. So types of polynomials would be monomial, binomial, trinomial. These are all considered polynomials, just a more specific name. Okay, it's kind of like a square is a rectangle, but a square would be the most specific name for a shape. So a monomial is one term, okay? It can be a number, it can be a variable, or it can be a combination of both and be a number times a variable. So an example would be the number 3, that's a monomial, or the number 3x is a monomial. Or it could be that there's more than one variable, 3x, y, z. That is still all one term. So that would still be considered a monomial. So the difference now between a monomial and a binomial is two terms, and that is going to be separated either by addition or subtraction. So the sum of two monomials. So if I did something like 3x plus 7y, that would be considered a binomial. Now, where I have to be careful, and we're going to talk about this as we go further into this unit, but if I did something like 3x plus 3x, that is equal to 6x, okay? So that would be considered a monomial, not a binomial, okay? So the terms have to be different. They can't be like terms. So a trinomial now would be three different terms. So let me challenge you to think of how could I write three terms, so the sum of three monomials, so that I am only using a single variable. Exponents. So I could do something like 3x squared. That again is still a monomial because that's all one term. Then if I did plus x, those are not like terms, so this would be a binomial, and then minus 6. Okay, now it has become a trinomial. So a polynomial is any of the above. A monomial, a binomial, and a trinomial are all considered polynomials. The way that you would classify something as just a polynomial is when it had more than three terms. Okay, the other thing that we have to be very careful of is this part right here. Right? You cannot have exponents that are negatives, fractions, or variables in the exponent. That would not make it a polynomial. So we're going to see a lot of exponents, but all of the exponents are going to be whole numbers. So if I go similar to the example that I did above, but I want to make it an extra term, I could do 3x cubed plus 2x squared plus x plus 4, okay? And that would be a polynomial. So for our first example, tell whether the expression is a polynomial, and then if it's not a polynomial, explain why. If it is, we're going to classify using the definitions from the previous slide. So in order to be a polynomial, my exponents must be whole numbers. So in this first example, my exponent is a variable, so that is not going to be a polynomial. Okay, and our reasoning would be because the exponent is a variable. All right, for my second one, I have an exponent, it's a whole number. I have a decimal in the problem, but that's okay because it's not in my exponent. Okay, so as long as your exponent is whole numbers, then it is a polynomial. So this is going to be yes. And then can we classify it as a monomial, a binomial, or a trinomial? So because this is two terms, again, addition is what's going to separate your terms from one another. Since this is two terms, this is a binomial. All right, example 3, again, exponents have to be whole numbers. So because my exponents are all whole numbers, yes, this is a polynomial. And then because it is 1, 2, 3 terms, I'm going to classify this as a trinomial. And one common misconception on a problem like this is how many variables there are in that problem. Is that a one variable or a multivariable polynomial? It's only one variable because it only has an x. The x happens more than once in the polynomial, but it still is just one variable. All right, and then for my last one, this is going to be no, because the exponent is a fraction. Again, the exponent has to be a whole number in order to be a polynomial. So the next vocabulary we're going to talk about is degree of a polynomial. And so this is what I just addressed in the previous question, was the difference between a one variable and a multivariable polynomial. A one variable is going to be that it just has an x or it just has a y. You might see it more than once, but that if it's only one variable, then that's that type of polynomial. So for a one variable polynomial, the degree is simply the highest exponent. Okay, so if we look at this example, the highest exponent is a 3, so the degree is 3. Right, easy as that. If it's multivariable, it gets a little bit trickier because it's the highest sum of the exponents of a term. So what I have to do is look at, I've got this term and I've got this term. What is the sum of the exponents for this first term? 3 plus 2 is 5, so the sum is 5. On the second one, 4x squared y to the 7th, 2 plus 7 is 9. So now what is the highest sum? The highest sum is 9, so the degree would be 9. So now we're going to classify by degree. So once we figure out what the degree is for a polynomial, we can use words to actually classify that polynomial. And a lot of these words you've seen before. So we've done constant, you've seen linear before. Again, now we're just making these in relation to that highest exponent. So if the highest exponent is a 0, let's just remember for a second, what is anything to the 0 power? Okay, 1 to the 0 power, 2 to the 0 power, it's always just 1. Okay, so what this means is any number, 1, 7, 15, these are all constants, but there would be no variable because the variable would have been x to the 0 power, which is just 1. Linear, the exponent is a 1, and you will never see anything written as x to the first power. Okay, that's not going to happen. So your example here would just be x or 5x plus 2. Right? The highest exponent is still 1, so that would be linear. And think y equals mx plus b. All right, so you have a variable, but you have no exponent. Quadratic is going to be if the highest exponent is a 2. Cubic, the highest exponent is 3. Quartic, the highest exponent is 4. And quintic, the highest exponent is 5. If the highest exponent is 6 or higher, this says nth degree, meaning that if you see x to the 6th, you would just classify that as the 6th degree. If you saw x to the 10th, you would classify that as the 10th degree. So a couple more vocabulary words. The first one is standard form. Standard form is how we are going to write all of our final answers for polynomials, and it's in order from the highest exponent to the smallest exponent. So if you were given something like 6x squared plus 10x to the 4th power, then to write this in standard form, you would put 10x to the 4th first, since 4 is bigger than 2, and then plus 6x squared. And this would be considered the standard form. Okay, coefficient is just a number in front of a variable. So if we're looking at the same example, 10 and 6 would both be considered coefficients. Whereas leading coefficient is the coefficient in front of the first term, but be very careful here. This is when written in standard form, okay? So that means that I would have to use the standard form and then look for the coefficient in front. So the leading coefficient would be 10. And then constant is a number without a variable. So for this problem, my constant would be 0 because there's nothing at the end. Technically, there's a plus 0 at the end. But if I had something like plus 7, then my constant would be 7. So in this example, we're going to take 12x squared minus 15x plus 13x cubed, and we're going to utilize all the vocabulary that we just talked about. So the first one is standard form. Standard form is rewriting the polynomial in order from the largest exponent to the smallest exponent. So since the largest exponent is 3, 13x cubed would be the first term written, then plus 12x squared, and then minus 15x. Okay, the degree is just the highest exponent. Since this is not multivariable, it is just one variable, you simply look for the highest exponent, which is 3. Then to classify by degree, we need to be careful now that we don't mix these two up. Okay, classifying by degree is linear, quadratic, cubic, quartic, quintic. Classifying by terms is monomials, monomial, binomial, trinomial. So for degree, if the degree is 3, this would be classified as cubic. Now for the number of terms, we have the same number of terms as the degree, 1, 2, 3. That's just a coincidence, okay? Remember, terms are separated by addition or subtraction. So for the number of terms, we have 3, and so that would be a trinomial. All right, the leading coefficient is going to be the number that is in front, but once it's in standard form. So since 13x cubed is the term that's in front, the leading coefficient is just 13. Okay, do not include the variable. The coefficient is only the number that's in front. Okay, example 9 minus 2k squared. So standard form, highest exponent to smallest exponent. Where I need to be careful here is that this value in front is negative 2k squared. And the 9 is positive, so this would be plus 9. So degree is the highest exponent. So the biggest exponent in this problem is a 2. And then for now, again, you can just keep going back to your vocabulary to check how to classify this. So to classify, it's either linear, quadratic, cubic, those words. So since the degree is 2, this would be quadratic. All right, number of terms. So we have 1 term, 2 terms. And so classification would be binomial. And then leading coefficient is the coefficient that is in the front. So since this is my first term, the leading coefficient is negative 2. All right, our third example, this is a monomial. This is all one term right here, okay, because there's no addition or subtraction separating these variables, but this is multivariable. So for my standard form, since it's only one term, it's going to stay the exact same. Okay, even if my exponents were out of order, you don't need to rearrange them within the one term. For the degree though, because it is multivariable, I need to find the sum of the exponents in order to get the degree. okay? So the sum, I would be adding 3 plus 2, and then be careful because C does have an exponent. It's just unwritten, but it is a 1. So 3 plus 2 plus 1 is 6. So the degree is 6. And for classification now, this is beyond our vocabulary words, okay? We had quintic and quartic. So this is just going to be the 6th degree. So number of terms we already talked about. This is all just one term, which makes this a monomial. And then there is only one coefficient, so the leading coefficient is -2. Two more examples, and these examples are going to have more than one answer. So if you come up with something different, that's totally fine. So create a quartic binomial, okay? So first I've got to know what these mean and what they represent. Are they talking about the degree or are they talking about the number of terms, right? So quartic is talking about the degree, and it means that the degree is 4. Quartic is 4. Binomial is talking about the terms, and it's saying that you have 2 terms, okay? So we're going to come up with a polynomial that has 2 terms, and the highest exponent is 4. So I know I'm going to have x to the 4th. Or y to the 4th, k to the 4th, m to the 4th. Again, you guys can create this however you want. And now, for the rest of it, you can fill in anything. You could put a coefficient of -4 out front, okay, plus or minus. Now, the only thing you have to be careful of for your second term is that the exponent cannot be 4, and it cannot be bigger than 4. Okay, if it's equal to 4, these are like terms. If it's higher than 4, you've now changed the degree. So I can just keep it simple and do +7. Okay, and that would be a binomial. And again, it's quartic because the highest exponent is 4. All right, so for the second example, create a cubic trinomial with a leading coefficient of 6 and a constant of -1. So let's break this down. Cubic means that the degree is going to equal 3. Okay, my highest exponent is going to be 3. Trinomial is telling us that I'm going to have 3 terms. So terms is also equal to 3. So I like to use blanks, 1, 2, 3. All right. Leading coefficient of 6 means that the coefficient that's in the very front of my polynomial needs to be a 6, okay? And I can go ahead and put the degree in here too. This is going to be x cubed because that's my highest exponent. And then the last thing it tells us is that we have to have a constant of -1. So that means that I'm going to have -1 at the end. And the constant is always going to be at the end when you're putting it in standard form because that's the lowest possible exponent. So now for my middle term, you've got lots of choices, okay? So I'm going to do plus. Again, it just has to be an exponent that is smaller than 3, and it can't be a constant because then I'd be able to combine it with the -1. So let's do plus 5x, and that would now be a cubic trinomial.